Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, I want to continue our discussion about the types of fuzzy membership functions by talking about the near function. And when we're talking about the near function, we're really going to be talking about the Gaussian as well because they're very similar. So last time we talked about this linear fuzzy membership function. And we said that it basically allowed you to pick a start point, pick a stop point, and that the fuzzy values were linearly interpolated between the two. And we said that it was a good idea if you weren't exactly sure what value you had in mind and how that value was going to change suitability as you moved away from it. So let's talk about instead, let's assume that you do have a value in mind. You know what sort of value you are trying to model suitability for, and that you want the suitability to decrease as you move away from that value, both higher as well as lower, right? Think of it like the Goldilocks, right? It's not too low, it's not too high, it's just right. That's accomplished using the near fuzzy membership function. So what that looks like, generally speaking, is going to be something like this, right? Our min, our max. This is our raw values. And then our fuzzy values, as always, go from 0 to 1. And so what the fuzzy membership function near looks like is essentially it's low, it comes up, it peaks, and then it comes back down, kind of like a bell shape, right? It looks something similar to a normal distribution, right? And so what happens is this center value here, right? This is referred to as the midpoint. Right, so this midpoint is a user-defined value. Right, you're picking this midpoint. And what this midpoint is this is the point that has a fuzzy value of 1. And then what happens is, as we increase the raw value, or we decrease the raw value away from this user-defined value, our fuzzy value or our suitability decreases. And in this particular example, it decreases rather quickly, right? Both lower values as well as higher values, right? The fuzzy value decreases kind of quickly. Right? The rate at which this sort of the width of this bell, right? This is controlled by the spread. Controlled by spread. And so one parameter we have is picking where we actually center this near value, or this near function. The other parameter we have is called spread. And what spread does is spread essentially controls how quickly the fuzzy values decline away from the midpoint, right? And so if we decrease the spread, right? If we decrease the spread, what happens is this bell will actually get more narrow, meaning the fuzzy membership values decline faster. Right? If we increase the spread, right, this cone gets wider, meaning fuzzy values decline slower. Fuzzy values decline slower. Okay. And so what does that mean in terms of suitability? Right? If the fuzzy values are declining faster, let's see just graphically what that would look like. Right, so let's go ahead and put our graph back up here. Right? So if this is our original fuzzy membership, right? If we do this in blue, right? If we decrease spread, right? That means that this is going to get narrower, meaning fuzzy values decline faster. Well, that means that it's going to come more like this. Right? This is more narrow. And so what that means is that we have less suitable area. Right, again, because what we're doing here is we're drawing lines from the x-axis up to where it hits the fuzzy membership function over to the y-axis to determine the fuzzy value. As we decrease the width of this bell curve, right, by decreasing the spread, we're making it so that more and more raw data values have lower and lower fuzzy values, which means that the overall result on suitability is that we actually have less pixels, right, with high suitability values, which means that we're going to have less suitable area. Right? Conversely, right, if we increase the spread, right, meaning we make this bell curve wider, it might look something like this. Right? And so if we increase the spread, right, we're slowing the decline of the fuzzy values, which means that our end result is going to be more suitable area. Okay? So again, with the near function, we have a target value in mind for what we want to have the highest suitability, and we know that values around that are suitable, but that suitability declines rapidly, both higher values and lower values. And we can control the rate at which those fuzzy values decline by either increasing spread, which will slow the decline of fuzzy values, right? It'll make the cone wider, or we can decrease the spread, which makes the bell curve more narrow, which means we'll end up with less suitable area. So as always, if you have any questions, please reach out. Thank you.